Good morning, Five Keys. What is up, Five Keys? I guess that's become my catchphrase. It is Tuesday morning, February 1st. We made it through January 2022. Bright and early, 7:45 a.m. Definitely a hot day for me. Today we're going to be looking at Module 2, Lesson 6, Solving Proportions. I'm very excited for this lesson. We're almost through with Module 2. It's going to be a good day. What do I want to say about it? Solving proportions. Okay, this is math that you've seen before, but they're going to, and by they I mean the curriculum writers of the text that we're working with, are going to reframe mathematics that we already know. Okay, and it is going to look quite a bit different, but I just want to remind you what this math is. So if I were to say 2/3, that's a fraction. I'm just going to draw out what that fraction might look like. And if you, so this is like a chocolate bar and it's cut up into thirds, okay? And we're going to define this fraction, and we can define fractions however we want to, really, as 2 of the 3 pieces are outlined in red. I don't know. We could say for every 2 poodles, there are 3 German Shepherds, or for every 2 out of every 3 dogs, there are 2 out of every 3 dogs are poodles. My point in this little tangent is that what this proportion means, or what this ratio means, is up to you in the way how you define it. So this could be for every 2 red marbles, there are 3 green marbles, or for every 3 marbles, 2 of them are green. Those 2 statements mean something very different, but it's up to you how you define it. All right. So if I were to say that, and then I were to say plus 1/6 of a marble, 1/6 of a chocolate bar. What does that look like? Well, there's my chocolate bar. I've cut this into 6 now, and I have 1 of them. And there's my red outline for the 1. What is that equal to? Well, to do this problem, we need to find what's called equivalent fractions, right? So we need to find the common denominator, then we add them up. When we're adding fractions, we don't add across the bottom and add across the top like we would in multiplication. We need to find the common denominator and write it in an equivalent fraction. So what is the common denominator? Well, the common denominator is 6. That is our least common multiple, right? So our least common multiple here is, our multiples for 3 are 3, 6, 9. Our multiples for 6 are, that's meant to be a colon, are 6, 12. So 6 is our least common multiple, or our least common denominator. So how am I going to get the 2/3 to look like a 6? Well, what do I need to multiply 3 by to get the 6? Well, 2. But I can't just multiply the denominator by 2, because that's going to change the value of the fraction. I don't actually want to do that. So I'm going to multiply the fraction by 1. 2 divided by 2 is 1. How do I multiply fractions? I multiply the denominator, I multiply the numerator. So I'm not going to change the value of this fraction. I'm not going to change the value of this fraction, because all I'm doing is multiplying by 1, but I am going to change the way it looks. So 2 times 2 is 4. 3 times 2 is 6. So now I know that 2/3 is the same as saying 4/6. So I'm going to rewrite this fraction down here, this problem, as 4/6 plus 1/6 equals 5/6. Now, visually, what I did here is I took this chocolate bar and all I did was draw a line, but I haven't changed the value or changed anything fundamental about this chocolate bar. I just proportioned it differently. There's that word again. So now I have 1, 2, 3, 4 out of 6 pieces are outlined in red, right? If this bothers you, let me just draw that part in red. So 1, 2, 3, 4, 5 out of 6 if I were to move this piece over here, 5 out of 6 would be the answer to the problem. But the part here that's relevant to what we're doing is here. I went from 2/3 to 4/6. This is just 1. So I can even erase that. And I can make this statement 2/3 is equal to 4/6. And that's a true statement. They're equivalent fractions or equivalent proportions. Okay. So what this lesson is going to be is reframing this with some algebra. So how can the use of unknown letters like A, B, whatever, X, Y, Z, allow us to do this more, allow us a different way of doing this that might be more applicable when we see it in the real world. Okay, so let's go to the movies. Let's go dun, dun, dun. Dun, dun, dun. Just pulling up my screen here. Bloop. Okay, so here we go. Let's go back to the top. Unit 2, lesson 6, solving proportions, state standard, blah, blah, blah. Learning target. In this lesson, you will solve and apply proportions. So proportions consist of 2 equal ratios. A ratio is just a fraction, such as A over B equals C over D, where B does not equal 0 and D does not equal 0. Why? Because whenever you divide a number by 0, the answer is undefined. Okay, 0 over some number is 0, but some number over 0 is undefined. We read it as A is to B as C is to D. So let's, I promise I won't sing again. I don't promise that, but I'll try not to because math is torture enough. Just pulling up my, gosh darn it. Gosh darn it, I'm trying to pull up my pen here. My computer's giving me a hard time. Okay, so when we say A is to B, A is to B, A is to B, as, that's my equal sign, C is to D. That's just a little bit of language that oftentimes we'll use when we're discussing proportions. So let's examine the type of problems that use proportions to solve them. Okay. The first section is teaching you how to solve a proportion problem. You will learn later in this lesson why you would use them. Okay, proportions are also handy for solving percent problems, which will be the next section. Okay, this is, so here's an example. They're saying 7 is to 8, or 7 over 8 is the same as M is to 12. This is an equivalent fraction. That's all it is. We're going to find it. We want to change the denominator here to from 8 to 12, and then find what the equal proportion would be. But it's a little dicier than what we've been doing because the numbers don't work out quite as readily. So let's see how they do it. Well, they said cross products. What is that? So they multiplied the 7 and the 12 together. Okay, now I'm kind of following. And they multiplied the 8 and the M together, and they came up with 84 equals 8M. And then they divided both sides by 8, and they ended up with this number here, 84 divided by 8, which simplified out to 10.5 equals m. So they came up with a non-integer answer. All right, so let's look at 7, 8 over equals m over 12 on our dry erase board here, or our digital board, because I think we have a little bit more to learn from it than what it's offering. Okay, I mean, they're gonna break it down for you, but let me break it down for you first, because I think I do. It doesn't matter. Sorry, I'm still kind of waking up this morning. 7 over 8 equals m over 12. So they did this a little bit differently, but this is m being divided by 12. So to get 1m, which is what I want, I'm going to multiply by 12. I could think of this as this is n being multiplied by 1 over 12. The fraction, right, that is equal to m over 12. So to get m112, I'm going to multiply by the reciprocal of that, which is 12 over 1, which is that, okay? Whatever I do to the right, I need to do to the left, and vice versa. And I end up with 84 over 8 equals m, which is what they came up with. So why did they do that extra step? What I mean by the extra step is instead of just doing the one step, which was multiplication, they did something a little funkier. They multiplied by the 12, right? They multiplied by both sides by the 12. And I'm not going to do this. So that's the step that they came up with. But then they went and they did this. They multiplied by the 8. And in this problem, it's a completely unnecessary step. They did it to eliminate the 8 from here, and they ended up with 12 over 7. I'm sorry, 12 times 7. The 8 went away. That went to 1 equals 8m. And then they did the extra step of dividing by 8, and they ended up with exactly what we got. They did it because they wanted to model for you this idea of cross multiplying. And that's probably an expression in a term that you've heard before. It's actually not called cross multiplying, although sometimes people call it that. They're using the term cross product method, which I've never heard before, which is to take the denominator on one side and the numerator on the other and multiply them together. And to take the denominator on the other side and the numerator on the opposite side and multiply them together. And the reason they're teaching this method is because it gets rid of the fraction. It gets rid of the fraction very, very quickly. And when your variable is in the numerator, meaning when what you're solving for, your unknown, is on top here, it's actually not really a useful method. It does become, but you're welcome to use it if it makes sense to you. It works, it's valid. Where this becomes very successful is if you have a problem where the variable is in the denominator. So if you have something like 7 over x is equal to 14 over 21, I don't know, I'm just making up numbers. Then this suddenly becomes a very useful thing to do, because by doing that, the cross product method to solve the problem, you'll end up with you'll get rid of the fraction and you'll have an unknown that's no longer in the denominator, and it'll look like something that's much more familiar and easy to solve. All right, in this case, the answer would be 3, I want to say. Yeah. Okay. X would be 3. So enough of that. Let's go back to our worksheet. Here's a cross product method and an explanation as to why it works. If they took the product of the denominators, which would be the least common denominator, or not the least common denominator, I'm sorry, it would be a common denominator. It might not be the least one though. And they're multiplying both the left and right hand sides by this common denominator. One of the factors is going to eliminate on either side, and you're going to be left with this cross product idea. Boom, cross multiplication. People don't take cross multiplication anymore because what was happening with students is that they would look at a multiplication of fractions problem and forget that there wasn't an equal sign there, and they would try to do the multiplication cross, right? And you only do this cross multiplication thing, this cross product, when there's an equal sign there and when you're solving the proportion. Okay. Here's a great example of when it's really useful. They're using cross product multiplication to solve this problem, and it's bringing the unknown, the x, into a more familiar form, because in the original form of the problem it was in the denominator. So it's not now, right? 6x equals 18 times 2. Okay, there's a video, we can link to it. A video within a video is becoming very, what was that movie? Inception? Anyway, so here we go. Here's some questions for you. Using the cross product rule, you would multiply x by what? Well, I would multiply x by the denominator of the proportion on the opposite side of the equal sign. That would be 5. You would multiply 7 by what? That would be 4. So you would end up with 5x times 7 times 4. Right? And here we go. They're going to ask us to solve it. Good grief, Charlie Brown. Good grief. Okay, so I'm going to take my cross multiplication here. This is going to give me 5x. Notice all I really had to do was multiply both sides by 7, and the reciprocal of the 1/7 the x is being multiplied by. But I do want to model the method that they're showing. And here we go. This is 7 times 4. Which is 28. And then we're going to divide both sides by 5. Or multiply by 1/5, which is the reciprocal of what the x is being multiplied by. By multiplying by the reciprocal, we end up with 1x, which is exactly what we want. 7 times 4 is 28. And we're left with a 5 underneath. This cannot be simplified any further. You could certainly write this as a decimal if you like. This would be 5 and 5.6, I want to say. Yeah. But you don't need to. 28 divided by 5, while we're accustomed to calling this an improper fraction at the level of algebra that we're at, we would prefer the improper fraction to a mixed number. And I would even prefer it to a decimal, but you're welcome to write as a decimal if you like. Just let's move away from the mixed number. The mixed number is something that's used in vocational math, but academically, we're not using it so much anymore. Okay, so here's another example that they're going to give you. Notice it doesn't matter where the variable is, you just need 3 constants, knowns, and 1 unknown. So here's our 3 constants, the 4, the 3, and the 8. And then and our 1 unknown. It doesn't matter that's in the denominator, just cross product is the solution. Here, I'm sure they meant to put the y in the denominator, but they didn't. I don't know why. No pun intended. So we're going to use this cross product rule. 3 times 3 gives us 9. Y times 5 gives us 5y. Those 2 things are equal to each other. I'm going to divide both sides by y. I don't know why I'm going crazy with my colors. Or multiply by 1/5. They're the exact same operation. This becomes a y, and 9/5 becomes 9/5. We could call it 1.8 if we desired, but let's not call it 1 4/5. Okay. Okay. For my money, 9/5 is the preferred answer. Okay, now we're getting into some fun stuff. All right, so notice they do not have parentheses when they write in the fractions, but we know from our unit on order of operations, and I think, yeah, from order of operations, that whenever you see a quantity, a sum or a difference in a fraction like this, we assume there to be parentheses. This is in fact a group. So when I do my cross product thingamajiggy, that group is there. So I end up with 4 times this difference and 5 times this sum. And I do need to distribute. So here they go, they distribute 4b minus 4 times 8, which is 32. And that's how they came up with the 32. 5b, 5 times 1b is 5b, plus 5 times 3 is 15. That's how they came up with that. And then this becomes a multi-step solving, a multi-step algebraic equation problem with a variable, with an unknown on either side of the equal sign. And we've done that earlier in the module. So they're subtracting 4b from both sides. That leaves them with negative 32. 5b minus 4b is 1b, which is pretty convenient. 1b, we're still left with our 15. Somehow it got deleted over here. I don't know why. They subtract 15 from both sides to get this 1b all by itself. Negative 32 minus 15 will end up with negative 47 equals b. So let's try one on our own. You ready? My recommendation is that you pause the video, do this all by your lonesome, and then come back and see how you did. Okay, we're back. So we're going to use our cross product rule here, and we're going to go 6 times n. So on our left side or our right side, doesn't actually matter. We can go 6n. And then on our right side, we're going to, I'm just going to keep the same color. We're going to, whoops, that was not a good line, teach. That 6 is not part of it. We're going to recall that there are parentheses here because anything that's on the top or the bottom of a fraction is in fact a group. So I need to multiply 5 by the entirety of this fraction. Okay, now this is math that we've done before. So I'm going to distribute my 5. And this is a review. This isn't what this unit is actually about. What is 5 times 2n is 10n. Remember that if we're multiplying different terms, in this case a 5 and a 2n, we can combine them. We can take the similar term, the similar number the similar number of 5 and 2, they're both numbers, and multiply them together. We are left with another factor of n there, plus 5 times 4, which is 20. But we can't combine the 10n and the 20 because they're different terms and we can't add and subtract them. All right, so now we have the same unknown on different sides of the equal sign. So I'm going to subtract 10n from either side here. Or I'm going to add a negative 10n. I'm going to add a negative 10n over here. I know it's a little confusing because they're not next to each other. But this is like saying, hey, I bought 10 bananas plus 20 bucks, and then I added a negative 10 bananas to my grocery list. So these bananas go to 0. That's by design. So I'm left with 20 on the right here, a negative 10n plus 6n. Is it a party or a war? Is an addition problem. It's a war because the signs are different, which means the operator is subtraction. I'm going to take the number with the smaller absolute value, and I'm going to take it away from the number with the bigger absolute value. So 6n has a smaller absolute value. That's its distance from 0. So 10 minus 6 is 4. And then I'm going to adopt the sign of the number with the greater absolute value. In this case, it's 10. And 10 is negative. So I'm left with a negative 4n. In order to get this a 1 to be the coefficient next to this variable, I'm going to divide by a negative 4. Negative 4 divided by negative 4 is a positive 1n. I'm not going to write the 1 in. We assume it's there when we're working with a very unknown. And then 20 divided by negative 4. 20 divided by 4 is 5. And then a positive divided by a negative is a negative. It doesn't matter that the size of the number that we're working with, but if you have one number that's negative and one number that's positive in multiplication and division, you'll always end up with a negative. So the rules are a little different than when we're adding and subtracting. We're referring back to module 1 now. Okay, so n is equal to negative 5 on this U-try. Is that what you got? I hope so. If not, see where you went wrong. If you're so confused, send your teacher an email. Okay. So I said I didn't say I wasn't going to sing anymore. I did say I was going to try though. So here's another U-try. It's an actual word problem. So an 8-ounce can of orange juice contains 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in a 12-ounce can of orange juice? Okay, so remember I said that you can set up, you can define a fraction to be whatever you want as far as what's in the numerator and what's in the denominator. As long as you're clear and as long as you're consistent through the problem. So here we have, I'm going to define my numerator, the top number, to be ounces of orange juice. And I'm going to define my numerator, my bottom number, to be milligrams of vitamin C, which would leave me with a proportion of initially for the 8-ounce one, I have 8 ounces and I'm left with 97 milligrams of vitamin C. For the second one, I have 12 ounces of orange juice. About how many milligrams of vitamin C are there? And then that's my actual question. I don't know. Notice I ended up with a variable in my denominator. I could have very easily switched these guys, define this as milligrams of vitamin C in my numerator and ounces of OJ in my denominator, but I didn't. And just it was actually an oversight. Okay, so but we're gonna follow the same rules. So we're gonna do our cross product here. 8 times x is 8x. Uh, 12 times 97. I can't do that in my head. Wah, wah. 97 times 12 gives me 1,164. I'm going to divide both sides by 8. And 1x is equal to 145.5. Well, what does that mean? Well, that's the milligrams of vitamin C that are in 12 ounces of OJ, which is what the question is asking. If the known proportion of 8 ounces of OJ to 97 milligrams of vitamin C, what is the fraction? Well, I defined it as 8/97. That's the, let me just change up the color here. I guess I should have followed their steps. Sorry if this is confusing. So the answer here is 8/97. And some teachers are pickier about this than others. You may want to do units here. So you may want to write out ounces of OJ, milligrams of vitamin C. I'm not going to. You need to keep the measure of the unknown in the same order, ounces to milligrams. If the new proportion has 12 ounces, given what will your other fraction be? Well, it's this. It's 12/x. And this is going to mess up the whole thing. And then we did this math over here. So this stuff in orange is what goes in this box. Okay. All right. Sweet. That's it for that. So congratulations. That's all done. Go ahead and do the practice, do the discussion, do the quiz, and then come back to the video. Okay. But don't go on to the quiz until you had a chance to do it on your own. I gotta do my spin trick. Okay, we're back. Let's pull up the quiz here. Is this it? Oh no, darn it, it's not. So we're gonna do this the way I suspect that they want us to do it, not the way that it really should be done. Here, all you have to do is multiply by 14. That's it, and then you're done. But we'll do the cross product thing. So 3 times x is 3x. 2 times 14, I'm going to just write out the answer to that is 28. Now I don't have to look at a fraction, which is nice. I'm going to divide both sides by 3. I'm going to divide both sides by 3. And I'm left with 28/3 equals x. Again, I prefer that you not use a mixed, quiet. I prefer that you not use a mixed number to answer this problem. I prefer that it be an improper fraction. You can use a decimal. No, I wouldn't even use a decimal here because it'll be sloppy. 28/3 is my preferred answer. A decimal would be 9.3 repeating. Let's see what the next question is, huh? What is the solution of the proportion? Bloop. Same exact thing. In this one, it is probably effective to use cross product because my variable is actually in the denominator. And by using this method, we pull it up into a numerator. So 3x is going to go on my left. 5 times 13 is going to go on my right. 5 times 13 is 65. X is equal to 65/3. This is my preferred answer. This would actually, if it had to be a fraction, would be 21.666 repeated, but I don't like the repeated. I would much prefer to see it as 65/3. Why? Well, if when you have a practical application in mathematics, if you're working in with physics or chemistry, eventually you will have to put a number into a calculator because you have to figure out how much to measure or how far the car is going to roll or whatever problem you're working on. But you don't want to get into the very, very end. So you want to leave everything as whole numbers, right? At 65/3 is exact. If I go to plug in 65.66666 into a calculator, there is an approximation at the end of it. And if we're working with something that has a big order of magnitude, what you feel like is a small approximation, by the end of the calculation can be quite large. So as you continue in mathematics and in science, we try to keep things exact for as long as we can. Okay, here we go. Now we got something fun. Okay, so they were nice to us, and they gave us this problem with the parentheses in it. They didn't have to. Whenever we see a fraction, we assume it's a group. So we end up with 5 times x minus 1. And we're going to do our cross product here. And this is equal to 2 times x minus 4. Now we don't have to worry about the fraction anymore, which is super cool. And yeah, if you're looking at this and thinking there are so many ways of solving it, you're right. You're right. But I do think that this is the simplest. So I'm going to distribute into these parentheses. This becomes 5x minus 5. And this becomes 2x minus 8. I'm going to subtract 2x from both sides. Or rather, let me rephrase this. I'm going to add a negative 2x to both sides. Exact same thing. But I think when you see it over here, it'll make a little bit more sense. And this is a review from an earlier lesson in this module. So here's my 2x. Here's a plus a negative 2x. That's going to go to 0 by design. Negative 2x minus a 5x. That's a mistake. Plus. Why plus? Because this is a positive 5x. What's negative 2x plus 5x? As positive 3x. minus 5 equals -8. If that's confusing to you, because this is a subtraction and not a negative sign, we can think of this as plus a -8, or to add the opposite. And then it may be a little bit more clear as to why this would be a -8. Now I'm going to add 5 to both sides. I'm going to work vertically for the sake of saving a little bit of space. This 5 goes away. That became a 0. That was by design. That's what I wanted. 3x is equal to -8 plus a positive 5 is a -3. I'm going to multiply by the reciprocal of 3, which is 1/3. I'm going to multiply by the reciprocal of 3, which is 1/3. I'm doing that. It has nothing to do with the fact that what's to the right of the equal sign is a 3. I'm trying to get this coefficient equal to 1, which I have. Any number by times its reciprocal is 1. Now 3 happens to be the reciprocal of 1/3. So this is 1, only this is a -3 multiplied by a positive 1/3 negative. It's not, it's being negative has nothing to do with that. It's a bigger number, or it has a bigger absolute value than the 1/3. It's being negative is purely because there is one negative and one positive. And whenever you have one negative number times one positive number, it doesn't matter how big or small those numbers are. It's always going to be negative. A negative times a positive, regardless of the value of the numbers, will always be negative. Okay, that was question number 3. Question number 4. A concession stand at a baseball game sells 3 apples for $2. How can you find out the cost for 10 apples? Okay, well, let's define our, I guess we can use text. Let's define our fraction, what it's going to be, okay? I'm going to say price is on top, number of apples is on the bottom. That's how I've defined it. Which, I don't know, it might not be I think the intuitive way would be the other way around, but I kind of want my my variable to be in the numerator generally, and I'm looking for cost of the cost. So that's why I put the price on top. Sorry, price and cost are the same thing. I should have wrote cost there. So the one that I know is $2 per 3 apples. I don't know how much the other one is, but I know there are 10 apples. So I'm going to cross multiply. 2 times 10 is 20. 3 times x is 3x. Divide both sides by 3. Divide both sides by 3. And I'm going to be left with 20 over 3 is equal to x. Okay, so in pure mathematics, 20 over 3 would be the preferred way to write it. That's a fraction in its simplest form. It's an improper fraction, but I don't want to work with it in mixed numbers anymore. And a decimal is going to be an approximation. Because it's a word problem, though, and there's applications to this word problem, I probably do want it to write it as a decimal, because we tend to talk about selling things in terms of decimals. So what's 20 divided by 3 as a decimal? We'll put 20 divided by 3 into your calculator and see what you get. I know 6 times 3 is 18, and then I'm left with 2/3, which is 0.666, repeating 666666666. So I'm going to say 0.67 and round it up, and this is how much 10 apples is going to cost at a rate of $2 for every 3 apples. Okay, That's it. Completo, no más. They're all drawings. Stop share. The next lesson is going to be on percents. Percents are exactly the same thing as proportions with a little twist. I know they can confuse people, but we're going to get through it. All right. Awesome. Thank you for being with me. Have a great day and good luck getting through module 2, lesson 6.